Did you know that nestled within the perpetually shadowed craters at the moon's poles, there are whispers of ancient water, not just a few molecules, but vast reserves of ice, locked away for billions of years? This isn't just a scientific curiosity, it's the single most important discovery that transforms our lunar dreams into a tangible reality. Think about it. Water is life. It's something to drink. It's a source of breathable oxygen when you split its molecules apart. And most astonishingly, it's a source of rocket fuel, hydrogen and oxygen, the very elements that can power our journeys deeper into the cosmic ocean. The moon, once seen as a desolate dead rock, is beckoning us with the promise of sustenance. This changes everything. For decades, the idea of a permanent lunar base was a science fiction fantasy, crippled by the immense cost and logistical nightmare of hauling every drop of water and every breath of air from Earth. But with lunar water ice, the equation flips. Suddenly the moon isn't just a destination, it's a resource hub, a celestial gas station. In ancient Greek mythology, Artemis was the twin sister of Apollo and the goddess of the moon. It's a fitting name for the NASA program destined to take humanity back to the lunar surface, this time to stay. The Artemis program is not a sequel to Apollo, it's an entirely new saga. Apollo was about planting a flag and leaving footprints, a magnificent yet fleeting sprint. Artemis is about building a home and establishing a permanent human presence. Its core mission is to land the first woman and the first person of color on the moon, symbolizing a future in space that is inclusive and representative of all humanity. First, we send uncrewed missions like Artemis 1, which successfully orbited the moon to test the powerful Space Launch System rocket, and the Orion spacecraft, our new deep space vessel. Then we send astronauts to orbit the moon, pushing the hardware and our procedures to their limits. Finally, we land. But this time, the landing is just the beginning. The ultimate goal is to establish the Artemis Base Camp, a long-term habitat on the surface, and the Gateway, a small space station in lunar orbit that will serve as a command center, science lab, and waypoint. Think of the Gateway as a harbor in the great cosmic sea. It's a staging point where astronauts can live and work for months at a time. Imagine waking up not to the gentle glow of a rising sun, but to the stark, silent beauty of the Earth hanging like a giant blue marble in the perpetual black sky. This is your morning view from the Artemis Base Camp. Your home isn't a sprawling house, but a compact, highly advanced habitat, partially buried beneath the lunar regolith to shield you from radiation and micrometeorites. Your morning might begin with a quick check-in with Mission Control in Houston, the voices of your Earth-bound colleagues traveling nearly 240,000 miles to reach you. Perhaps you'll slip into a state-of-the-art spacesuit, far more flexible and robust than the bulky suits of the Apollo era, and venture outside. Your job could be to pilot a pressurized rover across the cratered landscape to a mining site, where automated robots are extracting that precious water ice. Life inside the base would be a masterclass in efficiency and sustainability. Every drop of water, every molecule of oxygen would be recycled. Food would likely start as pre-packaged meals, but the goal is to grow fresh produce in hydroponic labs, lunar greenhouses where genetically engineered plants thrive under LED lights. Evenings would bring a chance to connect with loved ones back on Earth, the time delay a constant reminder of the immense distance separating your two worlds. Building a city on the moon sounds like something from a far future film, but the technologies that make it possible are being developed and tested right now. It's not about magic, it's about brilliant engineering. Early modules will likely be inflatable structures, like the beam module already tested on the International Space Station. These can be launched in a compact form and then expanded on-site. Solar panels are a great start, especially in regions near the lunar poles like the Shackleton Crater Rim, which receive near-continuous sunlight. To ensure an uninterrupted power supply, NASA is developing portable fission power systems. These are small, lightweight nuclear reactors that can provide steady power for years without refueling. The future of lunar transport is the pressurized rover. Imagine an RV designed for the moon, a mobile laboratory and habitat on wheels. Finally, the most crucial technology is life support. Advanced closed-loop systems are the key to long-term survival. These systems are the unsung heroes of space exploration. They will capture moisture from the air, from sweat, and from urine, purify it, and make it drinkable again. They will scrub carbon dioxide from the atmosphere and use chemical processes to regenerate breathable oxygen. The dream of a moon city isn't some far-off vision. NASA and its international partners have a tangible roadmap. The successful Artemis 1 mission in 2022 was the first major step. This wasn't just a test, it was a statement of intent. It was the firing of the starting pistol for humanity's return to the moon. The next major milestone is Artemis 2, currently slated for the mid-2020s. This will be the first crewed mission, sending 4 astronauts on a flyby of the moon. Then comes Artemis 3, targeted for the latter half of this decade. This is the mission that will land humans back on the lunar surface, near the resource-rich South Pole. Looking into the 2030s, subsequent Artemis missions will deliver the first elements of the Artemis Base Camp: the surface habitat, the power systems, and the pressurized rover. If the Artemis program proceeds on schedule, the first long-term human encampment on the moon could be a reality by the mid-2030s. The future is closer than you think. Why all this focus on the moon? Isn't Mars the ultimate prize? The answer is simple. The road to Mars runs directly through the moon. Our lunar neighbor isn't a detour, it's an essential training ground. The moon, just a 3-day journey away, is our coastal sea. It's close enough for a relatively quick return if something goes wrong. Yet it's a completely alien world where we can perfect the skills needed for interplanetary travel. Living on the moon will teach us invaluable lessons. We'll learn how to build and maintain habitats in a dusty, low-gravity, high-radiation environment. We will master the art of in-situ resource utilization, learning to extract water, oxygen, and even building materials from the lunar soil. These are the exact same skills we will need to survive on Mars. Furthermore, the moon acts as a logistical springboard. By using the water ice at the lunar poles to create rocket propellant, we can assemble and refuel our Mars-bound ships in lunar orbit. This cosmic gas station dramatically reduces the mass we need to launch from Earth, making missions to Mars cheaper, more frequent, and more ambitious. The moon becomes a trampoline, giving us the boost we need to vault across the solar system. When the crew of Artemis 3 steps onto the lunar surface, they will not be walking alone. They will be walking with the ghosts of the Apollo program, the echoes of Neil Armstrong's one small step. Men like Armstrong, Buzz Aldrin, and Eugene Cernan were the trailblazers. They proved it could be done. They are the giants on whose shoulders the Artemis generation now stands. The scientific legacy of Apollo is immense. The lunar rocks brought back to Earth are still being studied today, revealing secrets about the moon's origin and the history of our solar system. But Artemis also learns from Apollo's limitations. The Apollo program was a sprint, not designed for sustainability. Artemis is being built with longevity in mind through international partnerships and commercial collaborations. Why go to all this trouble? The answer lies in a fundamental part of the human equation: the drive to explore, to push boundaries, and to see what lies over the next horizon. It is this same impulse that drove our ancestors out of Africa, across oceans on wooden ships, and to the highest peaks of our own world. To be human is to be curious. We stand on a precipice of history, looking across a new ocean, the ocean of space. The plans for a lunar city are not just blueprints in a NASA file, they are the architectural drawings for the next chapter of human civilization. This is a journey for all of us, not just for the astronauts who will take those first steps back onto the regolith. Their journey is our journey, a collective human endeavor. Think about the children of today who will become the first lunar citizens. They will grow up seeing two worlds in their sky: the distant, brilliant sun, and the vibrant, living Earth. The lunar city will be more than a scientific outpost. It will be a crucible for a new kind of human culture. This grand vision requires more than just engineers and physicists. It needs you. What are your thoughts? What excites you most about the prospect of a city on the moon? What challenges do you foresee? Let your imagination run wild. The universe is vast and full of wonders, and our journey into it is just beginning. The moon is our first step, a shining promise in our night sky, inviting us to come and stay a while. The cosmos is calling, and it's time for humanity to answer.